Hi everyone, welcome back to this section 4.3 video. In this video, we're going to take a look at our first case of solving constant coefficient differential equations where we have unique roots, M1, M2. So when an auxiliary equation provides two distinct roots, M1 and M2, the solution would look like this: y equals C1 e to the m1x, that first root, plus c2 e to the m2x, that second root. So here we go. Let's solve y double prime minus 3y prime plus 2y equals 0. So this is, homogeneous and it's constant coefficient. And so let's see, what would a, b, and c? So, there's like an invisible one right here attached to the y double prime. So that means a would be 1. B would be -3, and C would be 2. And just for reference, what I'm stemming this from is, the general constant coefficient dE is A y double prime plus B y prime plus C y equals 0. And so the first thing we want to do is, here I'll call it like step one, jump to the auxiliary equation. So our equation is am squared plus bm plus c equals 0. And so let's plug in what we got. So this would be m squared minus 3 plus 2 equals 0. And, step two would be solving the auxiliary equation. All right. So we're basically just factoring this and solving for m. And so m squared minus 3m plus 2, we should be able to factor by now. But that just turns into n minus 1 times n minus 2 equals 0. And so m1 equals 1 and m2 equals 2. And so what we have are distinct roots because m1 doesn't equal the same thing as m2. So we have our roots, m1, m2. We're just going to use a general form of a repeated root solution, of a distinct root solution. And so let's do step 3, write up a solution. Okay, so, from up above, y equals c1 e to the n1x plus c2 e to the n2x. So our general solution is c1 e to the just x plus c2 e to the 2x. And that's our solution to this differential equation. And preluding a bit, this would be our y sub c solution, our complementary solution, but we'll get there eventually. Okay, so here's example 2. Why don't you guys pause the video, try it out, and then we'll see what we get. Okay, so this is what you should have gotten. A equals 1, B equals -1, C equals -6. We use our auxiliary equation. So it becomes m squared minus m equals minus 6 equals 0. That factors into m minus 3 times m plus 2. And we get our distinct roots, 3 and -2. And we throw them into our solution to this equation. We get C1 e to 3x plus C2 e to negative 2x. And that's our answer. So it's okay if you wrote, M2, M1 equals negative 2, and M2 equals 3, vice versa. It doesn't matter however you write them or which one's your M1, M2, just as long as they're both accounted for. Because it's just a constant attached to them, and constant could be anything. But okay, so that's our first case of constant coefficient DEs. We'll look at two more. But thank you for watching, and I'll see you in the next video. Okay, take care.